our formulas we learned in grade 10, linear equations, so when we're dealing with just straight lines. And we talked about a little bit about this yesterday, but we didn't actually look too much at the slope equation or the slope point form equation. So the first equation, slope, when would you use that formula? Does anyone remember? Well, it's called the slope equation, so it's going to give you the slope, and it's specifically when we have 2 points. So when you know 2 points and you want the slope, so when you have 2 points, and really it's really just rise over run, right? The change of y2 minus y1 over the change of the x's, and that's the difference of y over change of x, or rise over run. So when you have 2 points, x1 comma y1 and x2 comma y2. So that's when you'd use the slope formula. And we'd always need the slope to write any equation. So if we don't have the slope, that's where we're going to start. We need to get it. Always need the slope. Because no matter which equation you use, you'll notice the next two, they both have m in there. And m is your slope. They both need it. So we need our slope no matter what. So slope-intercept form, when do you use y equals mx plus b? You know your slope, m, and what else? Look at the name. Close. Y-intercept. So you know when you know slope and y-intercept. So we usually want to write most equations in slope-intercept form if we can. And it's really easy once you know the y-intercept. We can just plug it into that formula. You don't always know the y-intercept, and so that's when we use slope point. And so that's why it's called slope point, because you know a slope and you know a different point other than your y-intercept. So you'd use this when you know I should actually just wrote here, maybe right beside here, slope is m and y-intercept is b. Okay. So here when you know your slope, m, and a point, so a point other than the y-intercept. And it's actually derived from the slope formula. It really is the slope formula rewritten. And a point. And the point x1 comma y1. So if we don't know our y-intercept, we have to use the second formula. It has been a long time since you've seen this, so if you don't remember, it is okay. We'll practice and hopefully it'll come back. Okay, so let's try the first guy. So determine the equation of each line in slope-intercept form. So slope-intercept form is y equals mx plus b. That's the form they're wanting. Okay, slope-intercept form. So the first graph, are we able to figure out the slope? Probably. We have a graph, and slope is rise over run, so we need to find two nice points. So I'll use this y-intercept point, and maybe, where is there another nice point? Nice point means it crosses two whole number grid lines. Yeah, there's one at 3 and 3. Is that 3, 3? Right here. Okay, so those are two nice points. So we're going to use rise over run. So we always move up or down first and then right. And always start at the point on the left-hand side, right? Because when we read graphs, we read them left to right. So when we figure out our slope, which we don't have much room here, sorry guys, which is rise over run. We start at our left point. We're rising how much? It should be 2, right? Because we're here at 1, and then we're going up to 3. So we're rising two spots. We went up 2, and then right how much? 3. So it would be 2 over 3. So there's our slope. Do we know our y-intercept, our b value? Where does it cross the y-axis? At 1. And so now we can make our equation. So our equation is y equals mx plus b. So we can plug that in. Y equals, the m is 2/3 x plus the b value of 1. So there's your equation. Okay? Y equals 2/3 x plus 1. Oh, this is a b. B for y-intercept. Yeah, and that's just where it crosses the y-axis. The y value crosses the y-axis. The graph crosses the y-axis. Okay, so let's try this again for the next guy. So we'll find 2 points. I'll use again the y-intercept here of 1. And there's another nice point. So we use this guy right here at negative 2, I believe it is. X is 1 and y is negative 2. If I'm in your way, just let me know. Okay, so slope again is rise over run. So what are we moving here? So always move left to right. So what are we rising to go to this next point? Are we actually rising? Are we falling? We're falling how much? Negative 3. So our rise is negative 3. And then over our run is always positive because we're always moving to the right of 1. Now, would you leave it as negative 3 over 1? No, you'd write it as just negative 3. Anything divided by 1 is itself. And what's our y-intercept? Our b value? 1. And so what will the equation look like? Y equals negative 3x plus 1. Mx plus b. So m is our slope times x plus our y-intercept. Okay, the next guy, it says they gave us the equation, but we still want it in y equals mx plus b form. We just want to really essentially get y by itself. So how am I going to get y by itself? We want to isolate y. What would be my first step algebraically? Does anyone remember? Subtract 3x. We move the x to either side is our first step. So take care of the addition subtraction first. On this side, you'll be left with 2y because the 3x minus 3x cancel. Equals, and usually we write the x first and then the constant. Okay, so I'm going to write negative 3x plus 6 instead of 6 minus 3x. Because you'll notice the formula for mx plus b, the x goes first and then the constant. And then one more step to get y by itself. Divide by 2. And we'll leave things as fractions if they can't be reduced. Y equals negative 3 over 2x plus what? 3. Good old days of Math 10C when you were wee tots. Okay, next guy. Has a slope of 3 and a y-intercept of 4. Can we go straight to the equation? I don't know. Do we know m? Yeah, our slope. Do we know our y-intercept? B? Yeah. So y equals 3x plus 4. That one's too easy. The slope of 2 and goes through 3 and negative 1. So we know our slope, which is great. But in this case, do we know our b value, or y-intercept? And the answer is no, we don't. Because if we knew our y-intercept as a point, your y-intercept is always 0, comma, your y value. So like this would be the point 0, 4. Right? If our x value was 0, then this would be the y-intercept. But this is not the y-intercept. This is just a point on the graph. So in the event that they give us just a point on the graph, we have to use slope point equation. So we can't use mx plus b. We have to actually use y minus y1 equals our slope times x minus x1. And it essentially is the slope formula, just rearranged. You divide both sides by x minus x1, then you get the slope formula. So we have our slope of 2, so this is my m value. We have a slope of 2, and this would be my point x1, y1. Because we don't know our y-intercept, we know a point. Let's plug it in. Y minus what? What's our y1 value? Negative 1. So if you're subtracting a negative, y minus negative 1, what happens? Becomes a plus. Yeah, so you can write this just as y plus 1 if you want. Equals m, which is 2, x minus, what's my x1? 3. Okay. So they want us to write this in slope-intercept form. Y equals mx plus b. Okay. So right now there's two problems. Y is not by itself, and we have brackets. So what do you want to deal with first? Well, what do we have to deal with first? The brackets. So let's get rid of these brackets. So we'll leave this side is still y plus 1. This is y minus negative 1. So you realize that's where that became y plus 1 equals 2x minus 6, 2 times negative 3. And then last step to get y by itself, subtract the minus the 1. We have a plus 1, so we're going to subtract it to the other side. And there's my equation. Y equals 2x minus 7. Okay, one more linear equation to deal with. Goes through the points 5, 3, and 7, 9. So before we can ever make our equation, we need our slope. Do we know our slope? No. Can we get our slope if we have 2 points? Yes, we can use our formula y2 minus y1 over x2 minus x1. Right? Difference of their y's divided by the difference of the x's. In fact, it's helpful to label them like this first guy is x1, y1, this guy is x2, y2. So the key is to subtract in the same order. So if I'm doing difference of x, the y's, if I go 9 minus 3, I have to go 7 minus 5, right? You have to go this point minus this point, or vice versa, but the same order. Okay, so difference of our y's, y2 minus y1 would be 9 minus 3 divided by 5 minus 7 or 7 minus 5? Because we have 9 minus 3, we have to go 7 minus 5, x2 minus x1. 9 minus 3 is 6 divided by 2, or our slope is 3. Okay, so we're almost there. We now know our slope. Do we know our y-intercept? Can I go straight to mx plus b? No, we don't know our y-intercept, but do we know a point? Yes. Does it matter which point we use? No, doesn't matter, but let's just use this point here and our slope of 3. So whenever we know a point and a slope, we use slope point formula. Sub this in. Y minus, what's my y1 value? The y value in the point that we're going to use. 3 equals m is my slope. 3. And then x minus, what's the x value in the point? 5. Okay. So finish that off, make it y equals. Get rid of your brackets, and then you can move the 3 over, the minus 3 over. X minus 15. And then add 3. What's negative 15 plus 3? Negative 12. Okay. Okay, so that was, in a nutshell, a whole unit in Math 10. So now let's do a whole unit in Math 11 in a nutshell. Okay, so quadratics, we studied quadratics last year. And there was two formulas. I actually think we used P and Q instead of H and K, but it really doesn't matter. So there's two forms. There's factored form. This is called factored form. A factored form is beneficial in that you can see your x-intercepts. And then this is called standard form. And the benefit of standard form is you can see your vertex. So just to review, what does a quadratic actually even look like? What are we dealing with? We spent a whole few, like 2 or 3 units on quadratics. No matter which course you were in. Do you remember what they look like? It's okay. They're parabolas, right? They're just happy faces or smiley face or sad faces. Okay, those are quadratics. They're just basically a curved shape, like when you throw a football is a quadratic, okay? So when you have a quadratic, you're going to have a max or a min value. So let's review a couple things. You know you have, if your A value, so the A value is always in front. If it's positive, that means it's opening up, okay? So if A is greater than 0, it's opening up. And if a graph is opening up, will it have a maximum or a minimum? It's going to have a minimum, right? So notice it has a minimum if A is greater than 0. So again, and that's true for both, no matter what form you're looking at. So that A value tells you if it's going to open up or down based on if it's positive or negative. Okay? Now when it's in this form, this standard form, H comma K, be very careful of the subtraction here, is going to give you your vertex. So what is the vertex? What do you think is the most important part of a parabola? Yeah, like the max or the min part, right? This is right here is called the vertex. Here or here. Okay, that's your vertex. And when I ask you what the minimum or maximum value is, it's always in terms of y. So the max or min is located at y equals, so this vertex is always h comma k. So that would be the minimum. And then the h value gives you your axis of symmetry. And why do you think it's called the axis of symmetry? Cuts the graph in half, right? So this would be the axis of symmetry right there, where it cuts it in half. And that is the x value. So x equals h. And then factored form. So factored form actually, this doesn't tell you your vertex, it tells you your zeros. And what is a zero? We talked about them yesterday. What was another name for a zero? X-intercepts. Yeah, zeros are x-intercepts. And so this m and n is your x-intercept when it's in factored form. And you can get your axis of symmetry by averaging the two. So if you know you're crossing the x-axis in 2 and 4, halfway has to be where? 3. That's where it would be cut in half, right? Because the graph is always symmetrical. We cut in half. And so m plus n divided by 2, we average them, we'll get your actual axis of symmetry, the h value. And to get the k, if you want the vertex, you have to actually sub it into the equation. So let's look at a few graphs, or a few equations here. So the first guy says determine the max or min value. So what do we have in this graph, a max or a min? Max, yep, at, and maximum is always a y value. So how high did this graph go? At y equals what? 2. Okay, so max at y equals 2. Okay, the vertex, where would the vertex be located at? It's a point, what comma what? So x comma y, so 3 comma, vertex is 3, 2. We also need the axis of symmetry So what's the axis of symmetry? So where is the graph cut in half? Okay, yeah, it's at 3, and we would specifically say x equals 3. Because this would be, remember our vertical lines are x equals equations? So this is the equation, x equals 3. That's where the axis of symmetry is. And is it opening up or down? Opening, I think, is it happy or sad? Sad, so it's opening down. So that's opening down. And then we're actually going to, for this graph, I was going to go through the whole steps to get the y-intercept, but I'm not. I'm going to skip it. For this graph, we'll do it for the other ones. Okay. So next guy, it's written in standard form. Can you, sorry, opening down. That seat's not a very good spot, is it? I understand. Is it okay once you're moved? Move it as much as you need to. Okay, everyone have that down? So let's look at this guy who's in standard form. So we're comparing it to this equation here. So remember h comma k is our vertex. However, in the formula, the h value has a minus sign in front. Okay, so if we were to rewrite this in standard form, y equals 4, it would have had to been x minus what value to get plus 1? A negative 1. Okay, because if we compare it to the original formula, it had to have been a negative 1 to make plus 1 here, if the formula has a minus sign. So our vertex is where? What would be the vertex if it's h comma k? Negative 1, comma, oops, this is a minus 3. Negative 3. So that would be my vertex. Now, is this graph going to open up or down? Where do we look to figure that out? The very first number, our a value, will tell you if it opens up or down. So our a value in this case is positive. So if it's positive, we're opening up. So we're opening up. That's important to know. Since a is positive. Okay, we also have to do our maximum. So are we a max or a min if we're opening up? It's going to be a min at y equals, what's the y value would be? Negative 3, because this is the vertex, right? So the y value would be negative 3. And the axis of symmetry at x equals what? Where is it cut in half? Again, we look at our vertex. X equals negative 1. The last thing we're going to do, which we didn't do with the last one, is the y-intercept. Okay, so whenever you want to find the y-intercept, if you look at a graph, the y-intercept is located along this line here, and that's when x is 0. So in order to get the y-intercept, we have to set x equal to 0. We're actually make x 0 and solve for what the y would be at that point. And that would give me the y-intercept. Do we have an equation for this time? Yes. So we're going to actually sub in x as 0 to find the y-intercept. If you could actually just see it on the graph, then you don't have to. Otherwise, we always have to sub it in as, and even in linear equations, technically when we found the y-intercept, just hold on a second, I'll come back here. If I plug in x as 0 here, we're just going to be left with a constant of 1. And so that's why this is a y-intercept, because when you sub in x as 0, 0 times anything cancels, and you're left with just the constant. And so that's why your constant is the y-intercept. So So in any equation, in any type of graph, whether it's quadratic, linear, cubic, whatever, if you want the y-intercept, we make x equal to 0. Okay, so 0 plus 1, 1 squared, 1 times 4, 4 minus 3, 1. So our point would be x is 0, y is 1. That's my y-intercept, 0 and 1. Okay, it's a lot to take in. And last, let's look at a factored form. So just by looking at this graph, what could we tell about it right now? So minus 2, meaning what? Opening down. Okay. It's opening down, which means it will have a maximum value. We don't know where it is just yet. In factored form, what does that give us? The x-intercept. So we know that the x-intercepts are what? Compared to x minus m, x minus n. So it's a minus in the formula. So what would be the x-intercepts? What would it be here? It's x minus m. What would be the m value? Positive 1. And what would you have to subtract here to make it plus 3? A negative 3. So it's opposite signs always. Okay, so our x-intercepts are at 1 and negative 3. We know that about the graph. So what could that help me get if I know the x-intercepts are at 1 and negative 3? It can help us get our vertex because if we know, we can get our axis of symmetry, our h value, because it's the average of the two. It's going to be halfway between the two of these, right? So we can figure out from this that our h value, which is in our vertex, is the average between 1 and negative 3. It's halfway between, right? Because they have to be symmetrical. Everything's symmetrical with each other. So 1 plus negative 3 divided by 2, what does that equal? Negative 2 over 2 is negative 1. So is negative 1 halfway between 1 and negative 3? Yeah, it is. Okay. So right there, that tells me that my axis of symmetry is at x equals negative 1. So we know our vertex, we know the x value of the vertex is at negative 1. So right now, we know the x value is negative 1, but we don't know the y value. How do you think we could get the y value at the vertex if we know the x value at that point is negative 1? Any guesses? How do we find any y value if we know an x value? Sub it into the equation. Yeah. So to get our k value, or our vertex, we're going to sub in x equals negative 1 to our equation. Okay, because we know the x value at the vertex is negative 1. We just need the y value now. Plugging that in is negative 2 times negative 1 minus 1 times negative 1 plus 3. So I subbed in x as negative 1. Negative 1 minus 1? Nope. Nope. Negative 2. And negative 1 plus 3? Two. Okay, so you just have to multiply these together. What's negative 2 times negative 2? 4. And 4 times 2? 8. So what's my vertex at? X was negative 1. Y is So a little bit more work to get our vertex when it's in factored form. Okay, so now we know we've found its opening down. We know axis of symmetry. Could we get our max or min value now? Since we now know that it goes through the vertex is -1, +8. Yeah, so our maximum would be 8. So max at y equals 8. And then one more is y-intercept. So how do you get the y-intercept? We make what 0? Set x equal to 0. So that would be y equals -2 times 0 minus 1 times 0 plus 3. So we're subbing it into the equation. -2 times -1 is +2 times 3 is 6. So it's at 0, 6. Is our y-intercept. So that is basically a whole unit of grade 11, 20-1, 20-2 in a nutshell. So there's a lot of information there, I know. And I know it's been a long time. But this will help you with your homework today. So before you get started on some homework, I just want to review a couple terms. So yesterday we talked about function. What was a function? Maybe I'll just do it on the whiteboard here. Just really quickly. How do you know if something's a function? Any remember? No? The polynomial, you're thinking of polynomial functions. So polynomial functions, the exponents of the variables are only whole numbers. Yeah. So a function itself, each x has only one y. So meaning it passes the vertical line test. Okay, so passes VLT. Do you remember that yesterday? Vertical line test. So a graph is a function if it's drawn. If you could draw a vertical line at any point, it should only ever cross once. Okay? And we're going to be only studying functions. So we're going to look at exponential functions this year. We're going to look at logarithmic functions. And you'll be happy to note that functions, the graphing calculator can only graph functions. So if it can't graph it, it's probably not a function, okay? Because functions can all be y equals to be graphed. Another term we looked at is degree. Okay, how do we tell the degree of a polynomial? So the degree of a polynomial. We're not talking about like going to school and getting a degree. Degree of a polynomial. So let me give you an example. You tell me the degree. Okay, so the first guy, what's the degree of this guy? 3. Okay, so degree is, we look at each term. It's the degree of the highest term. We look at each term individually, and we want the highest power, okay, of the terms represent. So it's the highest power the highest power is really what we want, the highest power, right? The highest power of when we're looking at all the terms combined. So this guy, what would be the degree of this guy? 5. Don't be fooled, okay? Now, I have another term for you that we didn't talk about yesterday, leading coefficient. The leading coefficient. Who do you think the leading coefficient is in this first guy? 2. Yeah, this would be the leading coefficient. So the leading coefficient is the coefficient of the highest degree term. The leading coefficient will determine if the graph opens up or down. It'll determine the shape of the function. Okay? the leading coefficient has such an influence, whether it's positive or negative. So in this one here, who's actually the leading coefficient? The 4. Even though this is not written in proper order, because the highest degree is 5, 4 is the leading coefficient. Whoever has the highest degree has the most power over the function. Okay, so this term is really going to tell us what the graph will look like more than any other term. Okay, because it has the greatest degree. When you put an x value in there, it's going to have the most influence on what you get out of it. So this would be the leading coefficient. He has the most power because he's paired up with always the highest degree term. Okay. I want to define for you again turning points of a graph. So turning points are only located, what they're called are local max and min values. So the number of, local max or min value. So what do I mean by a local max or min? So we talked about yesterday of them as being humps. Okay, a hump, really, what I meant by a hump is like a maximum or a minimum value. So a graph only has a turning point if it has a max or a min. So how many turning points would this graph have? 4. 1, 2, 3, 4. Okay, so this is a local is isolated. So a local max, local min, local max, local min. Okay, just locally in itself. So this would have 4 turning points. Whereas, we looked at a cubic yesterday, like that. Does he have any turning points? No, because does he have a max or a min? No, he doesn't. He's only actually ever increasing. He doesn't go from an increase to a decrease. So this has 0 turning points. Okay, I think I'll leave it at that for today. So you can get some stuff done. Your homework is in your workbook. So these are the workbooks. Okay, it says workbook on it. Page 114 and 115 and 117. Okay. Now, if you were away yesterday, when you get to 117, you might need to watch the video notes to actually complete the homework. You can also get the notes on the website if you just want to copy them down. If you have a device on your phone, you can look it up. You're always welcome during homework time to go sign out a netbook from the library if you need to get the notes in class.